Voxxed Athens, and I'm with Douglas, who's giving the closing keynote about numbers. So let's start at the beginning. We have zeros and ones.
Actually, in the beginning, we didn't have zeros.
What do we have?
We had fingers.
Okay.
So 1, 2, 3. Zero didn't come until much, much later.
That's true, because it was was it in Arabic convention?
It was first in America. The indigenous American cultures figured out zero as part of a positional number system. But unfortunately, they didn't survive the Spanish conquest, so they're completely forgotten. So we get it later from the Indians.
Okay.
In India, they figure out the same thing, only in base 10 instead of base 20 as the Americans did, which turned out to be a much nicer number. And then they taught it to the Persians, who called them Hindu numerals, and they taught them to the Arabs, and the Arabs taught them to the Europeans, who called them Arabic numerals.
So that's my misconception there about zero. So in your keynote, you're talking about a shift in the way that we think about numbers.
Well, computing is all about numbers. And computers do virtually everything in the world now. Everything we do is mediated somehow with computers. But the only thing computers can do is manipulate numbers. They have no other power. So the fact that they're able to do everything that they can do just out of numbers is really kind of magical.
Yeah, I agree with that. I always feel like when I'm programming, it's magic in some way.
Yeah. So I'm going to be talking about that, and starting with fingers and moving all the way up to where we are now, and looking at some of the things that we do in computation which are just conventions but have turned out to be something that's much more deeply ingrained, that are also deeply problematic and interfere strongly with our productivity and with the correctness of the things that we're writing. And so I'm going to advocate that we try to shake free of that stuff and look forward.
So this is, for example, variable types in Java.
Yeah, so in Java, every time you create a variable or a parameter or a property, it's byte, char, int, short, long, float, or double.
Yep.
You have to pick one, and if you pick the wrong one, your program's going to fail, probably in a way that your tests cannot find. And there's no benefit from making that choice. That you're saving some bytes of memory, and the cache value of that savings is infinitely smaller than the time the programmer wastes in making that decision. So there are no benefits from having so many number types anymore. It used to be that there was a benefit a long time ago when memory was much more rare and much more expensive.
Yeah.
That if you, for example, the Atari 2600, which was the first computer that most people had in their homes, had 128 bytes of RAM in it. Really, really small. So on a machine like that, you're not going to want to waste 8 bytes on a variable if you could use 1.
Yeah.
And those attitudes still exist, even though they've stopped making sense many decades ago.
So you're suggesting that we move towards one number type?
We should have one number type. And in fact, I would consider JavaScript to be a superior or at least more highly evolved language than Java, because it only has one number type. The only problem is it's the wrong number type.
What type is it?
It's binary floating point.
Okay. What do you think it should be?
Decimal floating point.
Okay.
The problem with binary floating point is it cannot accurately represent decimal fractions.
So I'm sorry, this is my ignorance coming in here. What's the difference between binary floating point and decimal floating point?
It's powers of 2 versus powers of 10.
Okay.
So in binary floating point, when you start to go down the negative end of the number line, you get 1/2, 1/4, 1/8, 1/16, and so on. Whereas in the decimal system, you go 1/10, 1/100th, 1,000th, and so on. And the decimal thing is extremely compatible with the way we write numbers. And the binary form is not. That 1/10 cannot be represented exactly in binary floating point. So that means that almost every number that you write, if it has a decimal point in it, it's wrong.
Yeah.
That every one of them represents a tiny error, and those errors can accumulate.
A good example of that is probably in software where you get unexpected returns on your investments, for example, maybe.
Well, anytime you're dealing with money, it's a problem.
Yeah.
Because when you're adding up people's money, they have a reasonable expectation you're going to get the right sum.
Yeah.
And we're not guaranteed to do that if we're adding money in binary floating point.
So it could be quite an expensive problem potentially.
It
One
could.
party.
Yeah, and when binary floating point was first invented, it was recognized, we can't use this for doing business stuff. We'll just use it for scientific stuff. In those days, there were only two kinds of computing. It was either scientific or it was business. Today, there are a whole spectrum of stuff, but those were the only two that you could afford to do. And so you would have Fortran and binary floating point if you're doing scientific, and you'd have COBOL and BCD if you're doing business, and they were completely separate. And eventually, COBOL fails and is replaced by Java. Unfortunately, Java inherits from the Fortran lineage, not from the COBOL, and it doesn't know how to add money.
Okay.
So we stumbled into this weird place.
That is quite strange. So in Java, if we replaced the different number types, we would be left with float?
Probably double.
Double.
I recommend nobody ever use float anymore. There's just not enough accuracy in it, and you're saving half the size of a double. It's just not worth it. You should use double all the time. Some people are reluctant to use double because it's such a silly looking word. Why do we call a number type double? How does that make any sense?
I think float's probably stranger.
Well, it came from floating point, but yeah, float doesn't make a lot of sense either. So I think in a properly designed language, if numbers need an explicit type name, it should be number.
Thank you very much.
You're welcome.